Welcome back. I know there's a little lag in me posting videos. I'm going to try to post as many as I can tonight and as many as I can tomorrow to catch back up and get ahead. But more important than watching these videos is if you're struggling with a certain type of topic, to come to office hours. Dr. Solis and I will be in office from Tuesday to Thursday, or Tuesdays and Thursdays from 8 to 12. I've only seen 1 or 2 students. I know she hasn't seen that many either. And we'd be way more happy to answer your questions there than hopefully catching a few of your questions on a video with 3 or 4 problems. So with that being said, we're going to look at factoring. We're going to look at factoring all different types. Quadratic formula, regular, factoring out numbers, imaginaries, all that sort of stuff. This will be a huge review of all types of factoring. So let's get started because we do have a few different types of problems that I really want to try to get to. So the first one's going to deal with some imaginaries, going to deal with some rational equations. We're going to look at this, and anytime you see an X on the bottom, the first thing we do is make a note. I usually make it above it, and I make a little note to myself. Note, X better not make that bottom 0, because back in 3rd grade, your teacher taught you can't divide by 0. We know that. The 3's okay, because 3's never going to equal 0, but that X might equal 0. So X better never equal 0, right? If it does, bad problem, we're stuck, we can't do nothing. So we made that note, now we'll start doing the math. So we're looking for a least common denominator, get rid of the denominators. Nobody likes fractions. Our least common denominator is 3x, so we're going to multiply both sides by 3x and see some cool stuff happen. First thing we see happen is those x's cancel out, which is awesome, but that's why we have our note that x better not be 0, and the 3's cancel out. So now what we've got going on is some distribution of numbers, just an x and a 3, and we end up with 9x minus 9 equals 2x squared plus x. Let's make sure we look good. 9x minus 9 looks good to me. If I ever mess up, just send an email, send a text, like, oh, I didn't get that, and I'll make sure I fix it. So now we're going to move everything to one side and set it equal to 0. So I'm going to subtract you can do either side that you want to. I'm just subtracting this side because I like moving stuff to the left. So what you do to one side, you got to do the other, same way we did when we multiplied 3x. And we really end up with negative 2x squared plus 8x minus 9 equals 0. Sweet. That looks way too complex for me to factor. I don't even want to try. I think I'm going to end up with some imaginary numbers with all those negatives. So what I'm going to do is I'm going to jump straight to that quadratic formula, that song that you maybe learned in high school, hopefully learned, and you know by now. That whole negative b plus or minus the square root of b squared minus 4ac all over 2a. Awesome. So let's see what happens. So we end up with negative 8 plus or minus the square root of 8 squared. I'm going to go ahead and do that. 64 minus 4 times negative 2 times negative 9 all over 2 times negative 2. All right, let's take care of what we can take care of that we know is pretty simple. We know that negative 8 stays alone. We know that 64 we're going to leave alone for now. Let's combine all that stuff. 4 times 2, 8 times 9, 72. Those minuses, there's 3 minus signs, so it stays negative. So end up with minus 72 all over minus 4. Not too bad. Looking like there's going to be some nice easy numbers. Maybe an 8, a 4, and a 2 happening. So now we've got minus 8 plus or minus the square root of 64 minus 72. That's 6 away and 2 away, negative 8. Ooh, negative. That's going to end up with an I. We know that in our brains. All over negative 4. All right. So then what we're going to do is we're going to pull out that negative 8 over negative 4. Be happy with that because it's going to turn into 2 later. I'll leave it for now. Plus or minus the square root of negative 4. That's what I'm going to pull out. Times 2 all over negative 4. This is awesome. So we end up with 2, positive 2, because the 2 negatives make a positive, plus or minus. I'm pulling out this negative 4, and the square root of a negative 4, that's nice because 4 turns into a nice 2, and that negative turns into I. So we got 2I square root 2 all over negative 4, which we can do one more reduction, and then we're happy. It's going to end up being 2 plus or minus I square root 2 over 2. There's our answers. We could break that into 2 if we wanted to. We could break it into 2 plus, 2 minus. You could write it both ways. That looks awesome. I know that's a lot of steps, but hopefully that makes sense, though slowly taking each step. I like to take small steps, multiplying 2 numbers, taking care of the bottom, leaving it in a bunch of different steps instead of trying to do it all at once. Main thing to remember in that one, the first step is probably the hardest, looking for that LCM. You're looking for that least common multiple or least common denominator. In this case, it was 3x. Over here, it looks like it might be 6x. There's a hint. Down here, probably going to be the biggest denominator. Maybe something like that. I'll let you figure that out. But let's move on to the second type of problem, which is we've done solving by factoring. So I'm going to skip that, but I'll give you the little clue that you break that 9 apart, and you probably see something like 3 times 3. There's your jumping board for solving by factoring. And then we're going to hop to the ones where you have to use the square root property. Because a lot of times I see students try to do the square root property ones the way we just did with all those long steps. And it's actually a lot simpler. It's a lot easier than that. These are kind of cool because when you see this and you notice something's missing, the b term is missing, right? The x term, it's just got a squared term and a constant. There's no middle term. And when you see that, you can think of something cool. You can be like, oh, I can move each one to one side. I can split them apart and then just use my square root property that I know works. So I'm going to divide by 3 on both sides and wait and do the square root last. X squared equals 162 divided by 3. Hard to do in my brain. I'm going to type it over here to make sure I don't mess up. 162. You're probably yelling at me saying, I know what it is. How do you not know what it is? Divided by 3. Enter. 162 divided by 3. I should have had my calculator ready before I started this. Here we go. 54. We're looking. Oh, that's a nice easy number, huh? We got a little 54. And now we just square root it. Do a little factoring in the side of the square root. So x equals plus or minus the square root of 54, which we can probably break down if we wanted to. What are some ways 54 breaks down that makes it nice for us? Probably looking at, let's just start with 2 and see what happens. 2 breaks down into 2 and 27. 27 breaks down into 9 and 3. Ooh, that's where it's going to end up being nice, huh? So we've got a 2, a 9, and a 3. 9 breaks down into 3 times 3, right? So that 9 looks like our best term, huh? So let's pull that 9 out and see if we can pull anything else out. We pull that 9 out, we end up with x equals plus or minus 3 square root. And what are we left with? We took out the 9, so we're just left with that 3 and that 2. So square root of 6. And that's all we can do. Not too crazy. So that's why the square root property takes a lot less steps, right? That was a lot less steps than that first one. So if you notice that that b term is missing, you can use that property to kind of take a little shortcut. Could you use the quadratic formula? Absolutely, if your brain remembered to put a 0 in anytime you see that b term. Excuse me. All right. We already did the quadratic formula once today, so you can go back and watch that. If you need more help, I have more videos on this YouTube channel of the quadratic formula that you're welcome to watch. But this U sub is the last one that I really want to spend some time on. So let's look at this. Definitely not enough room right here, but I might use the bottom, and we'll see. So it's no different than factoring, but our brains have to kind of take a second step to wrap around it. And our brains have to kind of say, okay, I see an x4, I see an x squared, but I see nice easy numbers, like nice easy coefficients and constants. So what I'm going to do in my brain is I'm going to say, well, what if this x squared, technically, what if I just called this x squared this thing called u? I don't know what u is. It's a variable. It just stands for x squared. Well, what then I kind of can do in my brain is I can say, well, I know that x to the 4th is technically just x squared squared, right? And I know that this 6x is technically 6 times x squared. And then this 8 and this 0 kind of chill all by themselves. But what happens that's really cool is look at those 2x squareds in parentheses. I put them in parentheses for a reason, because now we can take those parentheses sections and replace them with u. Because we just said it. We just made it up in our minds arbitrarily. We decided to try this out. So now what we've got is u squared minus 6u plus 8 equals 0. Well, that looks factorable. And here's some review for factoring. So if you didn't like me skipping over the section that was factoring, here's a chance to practice it. Split that 8 up, probably a 4 and a 2. Looks perfect, 4 and 2. Now, what versions of 4 and 2 get me negative 6? Probably negative 4 and negative 2, because if I add negative 4 and negative 2, I get negative 6. So that breaks my factor down into u minus 4 and u minus 2, right? Equals 0. And I'm done, right? Not quite, Because what did we just say? Oh, we need to replace our u. We replaced u with something, right? X squared. So now we got to come back in and do it again. So what we're going to do, and at this point, you could take it one of two ways. I'll show you the way I do it, and then I'll kind of talk about the way you could do it. We're going to take that u, and we're going to put x squared back in. So x squared, because remember we defined u as x squared, minus 4, and x squared minus 2 equals 0. Okay, well, we know from properties of fractions, or properties of factors, that one of those is a perfect square, right? So we're asking ourselves, well, can we break these down anymore? Let's find out. So what I'm gonna do is I'm just gonna split them apart and see what happens when we set them equal to 0 individually. So we get x squared equals 4, and there's that perfect square I was talking about, right? So we get x equals plus or minus the square root of 4, which I'm gonna go ahead and jump to, which is 2. And there's 2 solutions so far. So now we've got 2 solutions. Let's check out that other one. X squared minus 2 equals 0. Not a perfect square, but that's okay. We can still solve it and end up with x equals plus or minus the square root of 2, which we don't need to make a decimal. Leave it as the square root of 2. That is a nice, easy number. And it's important to remember that's actually not 2 numbers, right? That is a set of 4 number solutions, right? So we're looking at -2, negative square root of 2, square root of 2, and 2 as our solutions. If you want to write them in a set, that's how a set of solutions looks. All right, those are the types of problems on this assignment. Hopefully that helps. Remember though, more important than watching this video and copying these notes and then doing the rest of the problems is if you have questions, come to office hours. We love helping. That's why we're here, and we want to be able to do that. So don't forget to log in. Don't forget to work on your discussions. Don't forget to study. We really need you to start working hard on making sure you know this material and you can upload it quickly and clearly, and we can see your work and your steps. That way we can give you full credit as quickly as possible. All right. Have fun working on the rest of these problems. Come to office hours if you need anything, and let us know as you work on these maths. Have a good day.